Okay, so we're in a big city and you want to go for a walk. You want to go from this corner to this corner. And you can only walk on the block. Otherwise, you'll be in the middle of the street, etc. In other words, one way to go from point S to point F would be to go this way. And we're always going to go in an efficient way. In other words, we will not start it as go down, go to the right, go up, and then go down 2, and maybe go to the left, right 2, go up, and then go back some, and then go up. We're going to go efficiently. We're going to go efficiently. So the question is, in how many ways can we go from point S to point F? That is the question. In how many ways can we go from the start to the finish? Now, let's look at this in a very careful fashion. One way is you can go 1 block to the right, a 2nd block to the right, a 3rd block to the right, a 4th block to the right, and then 1, 2, 3 down. That is, if we were going to record this, we would say right, 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 and then down, down, down. In fact, let's get rid of the commas. We can go to the right 4 times and then go down 3 times. That's one fact. Or we can go from point S to the finish, point F, as follows. We can go 1 to the right, and then we can go down 2, and then maybe 1 to the right, and go down 1, and then 2 to the right. But notice something. How many times did we go to the right? Well, we went to the right once, twice, 3 times, 4 times. And how many times did we go down? 1, 2, 3. But that's exactly what we had in the first one. We went 4 times to the right and 3 times down. 1, 2, 3, 4 times to the right and 3 times down. In fact, I have 7 decisions to make. 4, 5, 6, and 7. And I have to go to the right 4 times. And I have to go down 3 times. So maybe I can put the 4 rights like this, and the 3 downs like this. And that's the path. Let us see that path. Let's look at it. Let's look at this path. 1, 2, 3, and then 2 more. So we start here. We go down 1. That brings me to this point. We go to the right once. So I'm now on here. We go down once. That brings me here. We go to the right once. That brings me here. We go down again. Brings me here. Then we go to the right 2 times. 1, 2. Look at that. We arrived at the finish. The bottom line is you have to go down 1, 2, 3 times. You have to go down 3 times to get to F. If you only go down twice, you'll end up somewhere on this line. And you have to go to the right. 1, 2, 3, 4. You have to go to the right 4 places. So what's going on is, so every time, 1, 2, 3, 4, 5, 6, 7, every time I put down 4 R's for the right and 3 D's for down, that's the path. I mean, let's look at this path. I start here. I go down 1, I go down 2. I'm here now. Then I go 3 to the right. 1, 2, 3. It brings me here. Excuse me, I go 4 to the right. So another 1 to the right, and then I go down. As long as we write down 4 R's and 3 D's, we're done. The number of paths is going to be, well, 7 factorial to write down 7 letters. But, for example, if I call this D1 and D2 and D3 for the last one, there's 6 other ways I can have this same answer. I can have D2 and D1 and the R's, and then D3. Or, I can have D3 first, and then D2, and the 4 R's, and then D1. And these are the same. These are the same. There's 3 factorial different ways of me commuting the 3 D's. Wherever they are, I could get 3 factorial ways of doing it. But they're the same path. They're the same path. So I want to divide by the 3 factorial. Likewise, the 4 R's. R1, R2, R3, R4. The 7 factorial didn't take into account that those are the same letters. I can have the 4 R's from left to right. There might be some D's in between. I can have it R4, R3, R1, R2. Can write it 4 factorial ways where they're going to be the same exact path. So I need to divide out by that. Basically, the number of paths is the number, this is equal to the number of ways of writing 4 R's and 3 D's. And it's, since 4 plus 3 is 7, it's 7 factorial, 4 R's, 3 D's. So here is a number of ways that you can go from point S to point F. In fact, why don't we work this out? This is 7 times 6 times 5 times 4 factorial over 3 factorial over 4 factorial times 3 factorial, which is 6. The 4 factorials cancel out. The 6's cancel out. If I didn't make any arithmetic mistakes, 7 times 5, there's 35 different ways that you can go from point S to point F. Now, what if we do this in general? What if we do this in general? Not going to tell you how many lines there are. Or, well, there's M lines. Or, let me hold off on this for a moment. And then I draw like this. And there's the last one. Now, if you looked over here, there are 1, 2, 3, 4, 5 vertical lines. And you want to go from the left one to the right one. You ultimately want to go from here to there. So there's 5 lines, but you only want to go 1, 2, 3, 4. You only want to go 4 to the right. So if there's m lines, you're going to have m minus 1, you're going to have m minus 1 r's. And if there's n lines, you're going to have n minus 1 b's. So to go from here to here. Now remember, you can argue that that's line 1 and that's line 2. The problem is that when you get to line 2, you only went to the right one time. When you get to line 3, you only went to the right twice. So when you get to line m, you only went m minus 1 times to the right. So the number of paths will be m plus n minus 2. That's how many streets you're going to cross to get to here. How many corner points you're going to get to. Divided by factorial, divided m plus b. Divided by the number of r's, divided by the number of b's that you want to write. So basically what this is saying is you have 1, 2, 3, dot, dot, dot. You have m plus b minus 2 dashes, and you want to put m minus 1 r's and n minus 1 b's. And there's your answer. Now, we can play a little game with this. I can now say, you know what, I want to start here and I want to finish here. The only difference is that you're going to go up and to the left. So instead of r's, you'll have lefts. Instead of downs, you'll have ups or u's. So the formula is not going to change. In fact, you can never, if you want, you can never go from here to here, because the number of ways of going from here to here is the same number of ways of going from here to there. That is, if they ask you to start from here and go to here and count the number of ways, you can say, you know what, nonsense. I'm gonna start from here and I'm gonna go to here. I'm gonna count the number of ways. Now, why is that sound? Let's have a real configuration or a complete one. This is a one-to-one correspondence between the path from point A to point B and the path from point B to point A. Because if you go from A to B this way, well then you can go from B to A that way. It's never going to happen that, well, you know what, come on, I'm going to go from A to B this way, but you can't go from B to A this way. That's not going to happen. There's no path from B to A where you can't have the same exact path in reverse from A to B. So if you like to start on the top left and go to the bottom right, it's okay, even though they say go from B to A. You know what? If they tell you to go from C to D, You can also say, no, 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 no. I'm going to go from B to A, or A to B. And the reason is, so suppose you have this. If this is A, B, C, and D, this is exactly the same as if we turn the page over and we have B here and A here and C here and D there. 3 lines in the middle, 2 in the middle. So if you were asked to go from B to D, and if you flip the paper over, it's the same as going from B to D. But wait a minute. This picture right here is exactly this picture. That is, if you were asked to go from B to D, you could reverse the paper and go from B to D, where B is the top left corner. But that's the same as going from A to C. There's no difference. So you can always go from the top left if that's what you like, but the bottom line is this. Whatever they give you, if they say go from D to B, all you need to do is go one path. And the easiest one will be this. 1, 2, 3, 4 R's, 1, 2, 3 Ups. And that's it. So it's going to be 4 plus 3, divide out by the 4 R's and the 3 U's. That will be the answer. Okay, just count the number of rights you have to go and count the number of ups you have to go, and you'll be done. That was to go from D to B. Oh, let's just call it D. That was to go from D to B. Well, how many ways are there to go from B to D? Well, you can go down 3 downs, and then you can go 1, 2, 3, 4 lefts. So that's 7 turns. Divide by the 3 downs and the 4 L's. And you know what? You get the same answer. It's not gonna matter. Just go from one corner to the other, or one diagonal to the other. Don't go, if they tell you to go from A to C, do not go from A to B. Okay, all I'm saying is from A to C is the same as from C to A, which is the same as B to D, which is the same as B to B. Just go with diagonal. If you like videos like this, subscribe to my channel. Expect more videos to come like this. I hope you enjoy this type of mathematics. Please subscribe to my channel. Leave comments below. Thank you and have a great day.